All right, so I have shared my whiteboard. Can you see it?
Yes.
Okay. All right, so it is section 5.8, integration by parts. So do you have any idea about this topic already? Any clue?
No.
No, okay. That is perfectly all right. Okay. So first of all, I will write down the general form or basically the formula of doing it. I'll explain it to you and then we'll do the some practice questions. Okay. So integration by parts is basically used whenever we have two functions. Okay. Do you remember we used to apply the product rule in differentiation whenever we had two functions of x, like f of x and g of x? We used to use the product rule for differentiating such questions. Do you remember?
Yes.
Okay. So similarly, here we have two functions of x and we have been asked to integrate it. Okay, the only difference is integration. So first function is u and second function is dv by dx. Do not get confused by this dv by dx. Just think of these two things. This is first function, this is second function. That's it, okay? It has nothing to do with derivation or something like that, okay? It's just the formula and you just get to know why are we writing dv by dx. It's just for the formula only, okay? All right, so whenever you have two functions that are being multiplied and you have been asked to integrate it, the first function u would come as it is. Now you have to integrate the second function. Now Ranjani, here we need to do some rough working. We have already discussed the integral of a derivative is the function itself, right? So the integral of dv by dx with respect to x would be v, right? So integral of the second function would come here. Then we have a minus sign, integral. The integral of this function, which is this, would come here again. And then you have to derivate the first function. Don't worry, I will explain it to you. It is very easy. Okay. Now, this is the only thing you need to understand, and you will be able to do all the questions which can be solved by integration by parts. Okay. Now, what is the formula basically? You have u and you have dv by dx, okay? U is a function of x, dv by dx is a function of x. Do not think of it as a derivative or anything, not at all, okay? The reason behind writing it this way is just so we can write v here. What is v? V is the integral of second function. This function could be e to the x, ln x, x square, 5x plus 1. It could be anything, okay? It has nothing to do with derivation or something like that. This is just the formula. You just have to understand it, that this dv by dx is any function and this v is the integral of this function. Then you have a minus sign. Then you need to integrate again this v and you will write down the derivative of this first function over here. Okay. Now, did you understand something about the formula?
Yes.
Okay. I will just give you a random example and you will get a better idea. Let's say you have been asked to integrate x into sin x dx. And you will do it by parts. I mean, you can do it by parts as well, okay? Now, if you are doing it by parts, this and this, x and sin x are two functions, okay? So here you can see in your example, it has nothing to do with any derivative or stuff like that. So don't get confused at all, okay? We just have two functions. We need to choose one function as the first function, and first function is basically u, and the second function is dv by dx, and this is on the basis of my formula. Now in differentiation, we used to differentiate two functions which were multiplied to each other. And we used to say that first function would come as it is, then derivative of second function plus second function as it is into derivative of first function. So when we were discussing differentiation, we are not looking at the first function or second function. We can take any function as first function and any function as second function. You remember this, right? In differentiation,
Yes.
when we were discussing product rule particularly, I told you any function can be f, any function can be g. But yes, when we were discussing the quotient rule at that time, obviously we had u by v or maybe f by g. So we used to be very careful because we need to take the denominator first, and we take things carefully in quotient rule. But for the product rule, we just used to take any function as the first function and any function as the second function. But here you need to be careful, okay? You cannot take sin x as first function or x as first function directly. You need to think about it. And how will you think about it? Now look, this is the formula. Just think of, you have these two functions, x and sin x, right? Can you see my pencil right now? I'm moving it, or you are just
Yes.
able to see it when I write it? Do you see the pencil as well?
Yes.
Okay, right, okay. The thing is that this is the formula, and this u has to be chosen carefully. Why? Because we need to take we need to consider first function as that function whose derivative would ultimately um, end up to 1 or would simplify. For example, if I have x into sin x as my product, and if I take sin x as first function, okay, let's just try doing it this way. So tell me using the formula, let's say first function is sin x. This is just an attempt. And second function is x. Now second function is written as dv by dx. All right. So let's just use it. So u would come as it is. What is u? Sin x. What is v? V is the integration of this part. So now I will integrate x and I will get x square by 2. Minus sign would come here. I will integrate again. I will write down this integral as it is, and the derivative of sine is cos x. Okay, this is one situation. And again, Ranjani, I have an integral which I will again be doing it through parts. So the story would not end. Okay, and the other situation is if I use u as x and the second function as sin x, and now when I will apply the formula, I would get u is x, integration of second function, integration of sin x is minus cos x, minus sign would come here, integration of second function, and derivative of first function. It is 1 dx. Now minus x cos x, this minus would give me plus, and integral of cos x is sin x plus c. So you need to understand this thing, that if we had chosen u equals sine x, we wouldn't have had been able to simplify it. Since we chose u equals x in our second attempt, we were able to simplify it. So the choice of first function is important because of this reason. We need to choose such a function as the first function, which when we differentiate gets simplified. Okay, if you have a trigonometric function and if you differentiate, if you have sine, you will get cos. If you have cos, you will get sine. But if you have x square or x cube, it would ultimately reduce to 1 or any constant number. Do you agree? Are you there?
Yes, sorry, I was muted.
Okay. So did you understand this?
Yes.
Are you sure?
Can you repeat it once more, please?
Yes, definitely, definitely. Okay. Tell me, did you understand the formula at least?
Yes.
Okay. Were you able to understand this question and the concept I told you for first function and second function?
Yes.
Okay. So what part haven't you understood? What is the thing that is
Integration part.
okay? Look, this is our example. X sin x dx. Okay. We have two functions that are being multiplied to each other, and we need to use this formula. Now we can apply this formula very easily. We have two functions and first function would come here as it is. Integration of second function would come here minus integral sign. Integration of second function, this thing would come here as well. And the derivative of first function. The only challenge is to understand that which function would be the first function and which function would be the second function. Okay, let's do it by a hit and trial method. Okay, let's say we say that u equals sine x. Sine x is the first function. So sine x would come as it is because u is written as it is. Then v, what is v? What is v, Ranjani? V is the integration of second function.
Yes.
Okay,
So
so
it will be x squared by q.
excellent. Okay. Minus integration sign. The integration of second function would come here as it is. And the derivative of first function. Derivative of sine is cos. Now look. When we have ended up here, we can see that this integration cannot be solved like this. We would again and again get something of this sort. But when we attempted this question again and we chose first function as x and second function as sine x. So first function u would come here as it is. Integration of second function, integration of sine is minus cos. Minus sign is in the formula, integration. Then again integration of second function that was minus cos would come here and derivative of first function would come here 1. Now we can see here when we have minus cos in the integral only that there would be a time when we would be able to write the integral easily or directly. And this is sin x here. But here in this case we would have attempted it again and again, again and again. We would have been integrating it again and again, but we would not have been able to do it this way. Okay. So you need to understand this thing that selection of first function is important and you don't have to think about it every time. We have a trick for this. Are you clear with this thing that why is selection of first function important and why should we do it
Yes.
carefully? Sure.
Yeah. Yeah.
And did you understand the reason behind writing the second function as dv by dx?
Yes.
Yes, what is the logic? Please tell me.
Because you're integrating the
The second function?
second.
Yeah.
Yeah.
But this dv by dx has nothing to do with differentiation, okay? It's just a format of writing it. Just think about it as two functions. As two functions being multiplied, and this is the second function, and you need to multiply the integral of second function. Since the integral of dv by dx would be v, so just for keeping things simple, just to write this v here directly, we do it, okay? I would like to write this whole thing in English as well, the formula. because then you would be able to get a much better idea. Okay. Okay. Now, I will translate this whole thing in English, okay? So we have integral sign, we have first function, then we have second function. This dv by dx is nothing but second function. Don't think of it as a derivative or something like that, okay? So first function u, this is u, this is u. First function would come here as it is integration of second function minus sign would come here, integral would come here. V, what was V, Ranjani? V is the integration of second function. And then we have derivative of first function. Think of it like this only. So when we had x sine x, after thinking we chose x as the first function, so we need to write first function as it is, integration of second function, integration of sine x dx minus this integration sign would come here, and again we need to write the integral of second function. This would come in brackets, and the derivative of first function. X is the first function, derivative is 1 dx. Now we have x integration of sine s minus cos x minus sine would come here as it is, integral would come here as it is, integration of sine x is minus cos x dx. Now we have minus cos x with an x here, plus minus and minus would become plus, integration of causes sin x plus c. Now do you understand how to apply the formula?
Yes.
100%?
Yes.
Are you clear with this dv by dx? Do not get
Yes. It's
confused by the
integration.
formula. Yes, it's just the way of writing the formula, okay? But this is what it actually is, that we have two functions. First function comes as it is. You know, just like the product rule, where we used to say first function would come as it is, derivative of second function, plus second function would come as it is, derivative of first function. So obviously this is integration. We would have integrations here. And obviously things would be different in integration. Okay, so this is how you apply the formula. Okay, now we know that we have to think of the first function first and then choose, but you cannot think in exam. Okay, I mean you have to think, but we have a direct way of doing it. Okay, I want to write it as text. Okay, so the trick is LIATE. This is the trick of choosing first function. Okay. Every time you cannot think in exam which function would eliminate after differentiation. So you have to do it this way. Okay. All right. And what is this LIA? Are you able to read it?
Yes.
Okay. L is log. I is inward. This is not something like, this is a trick. Okay. It is not like you will not find it in your book or somewhere. It is a very famous word like BOTMAS, but it is a trick. It is a
Yeah.
short. This is algebraic function. I will just write down like that. This is trigonometry and this is exponential. Now you have this rule. And what is this rule exactly? Okay. If you have a question, let's say we have just discussed this question. Okay. And you have to integrate it. And you have to integrate it by parts already. So you need to choose first function. Now on the basis of this, you will choose your first function. We have x is an algebraic function, and sin x is a trigonometric function. So this comes first and this comes second, okay? So this is going to be the first function and this would be the second function, because in this order, algebraic comes first, okay? This is
Okay.
basically used to choose u to be function that comes first. In LIATE, we have different types of functions. For the choice of u, for selection of u, you need to choose function that comes first. Now you had x, you had sin x. X is an algebraic function, sin x is a trigonometric function. So x is algebraic function. In this rule, in this way, the algebraic function is coming first. So you will choose this as u, right? Do you get the trick?
Yes.
Okay. You can note it down because we
Yeah,
will
I
be
know.
using it for other questions. I'll just rub the extra things. These tips are very, very important for time management, because when sitting an exam, obviously you know the concepts, but you cannot waste your time in thinking like that. Oh, I've rubbed that as well. Sorry. LIATE. This is exponential. This is trigonometric. This is algebraic, inverse, and logarithmic. So are you done with noting it down? Should I discuss a
Yeah.
question now? Okay. So we have another question. You have to integrate x squared e to the 2x dx. Now, Ranjini, we are very clear with the fact that we cannot do it through type 1 and type 2. We cannot we do not have 1 over a squared plus x squared. We do not have f dash of x over f of x. So clearly those two options are cancelled. We cannot break it down further using partial fractions. Okay. Now the question is that we can think of it by doing it through substitution and product rule as well. Okay, so the first choice of preference should be the integration by parts, not the product rule. It's integration by parts, because if you apply it, you can think of it, and you would be able to know if you would be able to integrate it or not. Okay, substitution is basically you would be attempting, you would be first considering u equals x squared and 2x, and that takes time, right? I mean, it could be that you are able to do it that as well, but your first preference should be integration by parts. Okay,
Okay.
right?
Yes.
Okay, so now we will use our formula. So according to the formula says first function comes as it is, integration of second function minus integral sign, integration of second function and the derivative of first function. And this is the formula, okay, just for your reference. Okay, so now first thing is to choose the first function. Now this is x square and this is e to the 2x, and you have this. So I want you to tell me which function is going to be my u, which function would be u, and which function would be dv by dx? Yes.
Square will be u.
Sorry.
X square will be u.
Excellent. Why? Because it is algebraic, and e to the
Algebraic, yeah.
2x is exponential. This is coming first, and this is coming second. So this is how we choose. Okay. All right. So we have x square. Right. So u comes as it is. Okay. So x square is u. This is u, and this is dv by dx. Okay. So first comes as it is, and we need to integrate the second function. Obviously, we will do it stepwise. So we will just write it down like this. Minus sign would come here. Integral sign would come here. And v, what was v? V was the integral of second function. So again, this thing would come here. Okay, do not get confused with these two integral signs. And derivative of first function would be, tell me, what would be the derivative of first function? Derivative of x square is?
X. 2x.
Very good. Okay. Now x square would come here. What is the integration of e to the 2x? E to the 2x would come here directly. 2 would be divided minus. Again, we have the same integral. So this is the answer. And 2x would come here. Dx, 2 and 2 can be cancelled. And we have x square e to the 2x by 2 minus integration sign e to the 2x x dx. Again, we have not solved it completely. Okay, we have this integral now, and now we need to integrate this integral. Okay, let's do it. So now how would you integrate this integral? Again, you will use the by parts method. Okay, and what would be your first function now? E to the 2x or x?
X.
Very good, because x is algebraic and exponential is the second option. Okay. So as per our formula, u would come as it is. Again, we need to integrate the second function. The integral of e to the 2x is e to the 2x by 2. Minus sign would come here. Integral of second function would come here. Derivative of first function. Now we have x. Derivative of x is 1. Initially, we had x square. So we ended up getting 2x. And our choice of first function is basically has become 1, okay, or has become a constant in short. So this is x e to the 2x by 2 minus, okay, I will get 1 by 4 e to the 2x. Why 1 by 4? Because integration of e to the 2x, e to the 2x by 2, and we had this 2 already, okay? So now we have this part and we have this part, okay? We need to write it down together. So the final answer would be x square e to the 2x by 2 plus, sorry, not plus, we have a minus sign here, minus x e to the 2x by 2 minus 1 by 4 e to the 2x. Is it clear?
Yes.
100%?
Yes.
Okay. All right. Now, okay. Now we have a different type of question. Have you ever thought what would be the integral of this natural log function?
Integral. Will it be 1 by x?
Okay, 1 by x is its derivative, right? The derivative of
Oh, yeah.
ln x
Um,
is 1 by x. And if we have been asked to integrate a function of this type, we get ln f of x plus c. So we have only discussed such type of things. We have never ever, found the actual integral of ln x. And today we will do that. Now, think of this ln x as 1 into ln x dx. Now think of it as if you have two functions that are being multiplied to each other, and you need to do it through integration by parts. Okay. So, and I agree, one is not a function of x, and this formula or this method is basically used whenever we have two functions of x, but natural log of x is an exception. Okay. In mathematics, we have done the integration of natural log of x to this method. The integration by parts method and the product rule method is applicable even for constant numbers as well. If you differentiate this 2x by dx by doing it through parts, let's do it. First function would come as it is integration, derivative of second function plus derivative of first function is 0 into the second function as it is again 2, or if you do it directly it would be 2. So in short, these formulas are also applicable for constant as well, but we know that whenever we have a constant in a derivative or integral, we can always take it out. So this is the reason behind saying that whenever you have two functions of x, only then we use these formulas. Okay, because we can always take out our constant. So this formula in general holds for a constant into a function of x as well, right?
Yes.
Okay, so we know that this formula would still be applicable on 1 into ln x, right? Now let's choose our first function. Log, inverse of trigonometric functions, algebraic, trigonometric, and exponential. So what would be our first function?
Our first function would be,
Ln x, because we have
yeah,
a log here and we do not
yes,
have anything for constant. Okay, so this would be our first function. Okay, and now what was the rule? First function, second function, first function would come as it is, integration of second function minus
second
integration sign,
function.
integration of second function, derivative of first function dx. Okay, so first function, that is ln of x, would come here as it is, and we need to integrate the second function. Okay, this is dv by dx, and this is u. Do you agree?
Yes,
Sure.
yes,
Do you think it's correct?
it is.
Very good, excellent. It is correct. I was just trying to confuse you. Okay. So now help me apply this formula. Okay, I'm doing it by myself. I want you to help me. Just take your time and tell me what should I write? Which function would come as it is?
X.
Ln x, and
Yes,
integration of second
one
function.
X.
Integration of one is x minus sign, integration sign. Again, what would come here?
X.
Excellent. And derivative of the first function. Derivative of ln x is this. So it would be 1
One
by
X.
x dx. We can cancel these out. We will get x ln x minus integration of 1 with respect to dx. It would be x ln x minus x plus c. This is how you basically integrate it. Are you clear with this?
Yes.
Perfect. Okay. So any questions?
Oh no, it's fine.
Sure.
Yes.
Okay, because we are done with the integration chapter and now I will go to chapter 6. Obviously, I will discuss the questions because this is the most important topic chapter. But I will start with chapter 6 today, and we will take out some time in our Wednesday's class to discuss more questions of integration, the questions you would have problem with. Okay. All right. So let's talk about our sixth chapter, finding roots. So let me just clear it up and I'll use different color. Let's write it down as that. Okay. So the topic is finding Roots. Okay, and this is basically the 6.1 section of your book. Now, what are roots? My first question is, what are roots? If you have a function f of x equals x squared plus x minus 6, what do I mean when I say you have to find the roots of this function? What is the meaning of this statement as per your knowledge?
Roots as in where the um, curve crosses the x-axis.
Excellent, excellent. So what does that mean? That means you need to find the values of x when this function is equal to
0.
0. Very good, very well done. Why? Because this is our y-axis, this is our x-axis. Y-axis is basically for f of x in this case, and this is x. So if I have a curve, any curve, I'm talking about here in general. I'm talking about this in general. Let's say this is a curve, and the roots would be this part and this part. So at these two values of x, f of x is 0. F of x is whatever x is, and f of x would be 0, and whatever x is, f of x would be 0. So this is basically what roots are. Okay, roots of a function are values of x where function is 0. Okay, you need to know this concept. And you have been finding the roots. How? Okay, let's do it. Let's find roots by f of x equals 0 by using this equation. Okay, this implies x squared plus x minus 6 is 0. Now I want you to find the roots. How would I find the roots? By making factors. So I need two numbers such that when I multiply them, I get minus 6x squared. And when I add them, I get 6. I get x. So two numbers are, what are the two numbers in our case?
3, minus 2 and 3.
Very good. Now I can take x common. I would have x plus 3 minus 2 can be taken common. I will have x plus 3 equals 0. And finally, I have x minus 2 and x plus 3 equals 0. This is x equals 2 and x equals minus 3. Okay. Now, basically, we know how to find roots. But here we are not going to talk about finding roots. In fact, we will just look at a method which will tell you that whether there would be a root between two x values or not. Okay, I'll tell you. Let's say
Why do we use the formula b square minus 4ac is greater than 0 or less than 0?
b
Even that's for
square,
finding roots, right?
b square minus 4, exactly, okay, exactly. And we see if it is greater,
Less
if
than
it's less
0
than
or
0,
greater
then
than 0.
exactly, okay, very well said, very well said. But here, we are going to look at it in a bit different way. Okay, you are correct. We usually do by using this as well, but here we need to use another logic as well. Okay, and what is that logic? That logic is that what if I ask you to tell me, okay, so it is fine if we have a root between between minus 4 and minus 2. So in this case, you would come across this type of a question. Okay. Now, obviously, this is correct, but in our example, we need to find a root between minus 4 and minus 2. We don't have to find a root. We basically have to tell if there would be a root or not. Okay. Do you understand the
Okay, I
question now?
can.
Very good.
Yes.
Excellent. And this -4 and -2 are basically x's, okay? They would give you directly -4 and -2, but you should know that this -4 and -2 is basically x equals -4 and x equals -2. Okay, okay. Now let's think about it. Okay, let's find out the value of f at -4. Why? I will tell you. What would be the value at -4? What would be the value? I need to use this formula, right? -4 square plus -4 minus 6. It would be 6. Okay. And at -2, it would be -2 square plus -2 minus 6. It is going to be -8. Now you need to notice one thing. This is positive and this is negative. Let's talk about it on graph. Although we know that, just look at this x equals -3. Can you see x equals -3?
Yes.
We know that there is a root, but we don't have to tell them by finding it or by using b square minus 4ac less than 0. We need to do it by this method. Now we have basically um, ended up getting that the value, we have -2 and -4, okay? And basically we have that function at -4 is somewhere here because it is positive, right? And at -2 it is somewhere here. So the graph would be basically, it is somewhere here. It would be something of this sort, okay? The only thing we can see is that yes, there is a point between -4 and -2 where our graph is cutting the x-axis. And this was very clear by seeing that one value is positive and the other value is negative. Whenever we are going from positive to negative, or negative to positive, obviously, definitely our graph is going to cut the x-axis. Do you understand this?
Yes.
Sure?
Can you repeat?
Okay, definitely I can repeat. You don't have to, you have to tell me directly, okay? I don't mind that. Okay, look. So here the question is a bit different. They are saying find if we have a root between -4 and -2. This -4 and -2 is basically x equals -4 and x equals -2. Okay. And you don't have to find the root, okay? You don't have to do it the way we just did it initially, but you need to do it through another method. And that other method is you need to find the value of function at this point. It is 6. And you need to find the value of function at this point. It is -8. So it is positive at -4 and it is negative at -2 at the second point. Okay. Now this is the graph. This is x equals -4 and this is x equals -2. So at -4 we had that f of x is positive. So it would be somewhere here, anywhere in the positive side. Okay. And at -2 f is negative, it is somewhere here, and our graph is connected. Okay, so if it is going from positive to negative, it implies that there would be a point at our graph where it would be crossing the x-axis. At this point the value of function would be 0, and this is basically what the root is. This is the root and this is -3. We have just calculated it. Okay.
Okay.
Did you understand? I can explain it again as
Yes.
well.
No, I got it.
Sure, 100%?
Yes.
Perfect. Okay. So now, this is the concept. For exam, I'm not telling you to do rote memorization, not at all. I've explained the concept, but for exam, the only thing you have to do is plug in this -4 in F, this -2 in F, and see if it is positive and negative or negative and positive. It could be that this value was negative and this value was positive. It means the same thing, okay? If we have, if the sign is changing, if the function's sign is changing from here to here, it means that it would be crossing the x-axis. When it is crossing the x-axis, it means that the value of function would be 0, and that value of x, which corresponds to the zero value of function, is basically your root. Do you understand it now?
Yes. So that means that if the signs are different, we have a root.
Exactly, exactly. So it could be that we had a negative sign here and a positive sign here. Okay, the only thing you need to know is sign change. Sign change. Okay, sign change is the key. Sign change is the key. Just get remember sign change. Okay.
Okay.
Okay, perfect. Now, before going on with further topics, I would like to talk about graphs here because that is important. And today we will just talk about graphs of quadratic functions and linear functions, and then we'll go to cubic functions when we will come to those topics. Okay, so let's talk about the graph of a linear function. Linear function. Okay, so all right. So what is a linear equation? Any idea of what a linear equation looks like? Any guess?
Y equals mx plus c. Oh no, that's the
Yes, no,
graph.
no, you're right, you're right. Y equals mx plus c, right? This is what you said.
Yeah.
You are right. Y equals mx plus c is the equation of a straight line and it is a linear function as well. It is a linear equation as well. Okay. So let's just draw different types of equations here. Let's discuss all the types here for the sake of comparison, just so we can compare. We have one, two, then we have a third type as well. And yeah, okay, right. Let's go with these types only initially. Let's use different color. Okay. So, okay. Let's say I have this line. Okay. Now, you should understand the fact if a line is passing through this point, it means it has a positive intercept, right? C is positive because C is the intercept, M is the slope. And since it is going upwards in this direction, M is positive. Excellent. Okay. Let's talk about another type where you have this line. Okay. Now in this case, we know that M is again positive and C is 0 because it is passing through
Passes
the
through the
origin. Very
zero
well done.
origin.
Very well done. Okay. And let's talk about another type where we have this line.
It is negative gradient.
Excellent. And what is the other thing? C
Passes
is
through zero.
very good. So you know about straight lines. Okay, you know how to plot a linear function. Very good. Okay, that is perfect. Let's talk about quadratic functions now. Okay.
This is the
Hmm.
smiley graph. Those smiley graph, like a parabola.
Parabolas. Yeah. Okay. Excellent. Very good. So let's talk about the most simple version of a parabola. I mean, every parabola looks same, but if we draw it for y equals x square, it would be like this, right?
Yes,
Very good. Okay. And it is upward because we have a positive
positive.
coefficient with x square. That is one. Excellent. Okay. All right. Let's talk about another one. Before talking about another one, let's talk about the other type over here directly. And the equation of this one would be y
Negative
equals
x squared.
very well done. Okay. Now let's talk about uh okay. Let's say if your equation was y equals minus x squared plus 2, so what would change? For minus x squared, this is the graph, and when we are adding 2 to it, it would simply move 2 units upwards, right? So, okay.
Upwards. Yes.
Okay, and another thing is now we know that it would move 2 units upward, but we need to know the points which would cut the graph, okay? I mean, I know that it would be of this shape, but I need to know these points as well. So how am I going to find these points? This is the x-axis and this is y. And the beauty of x-axis is that whenever the graph is cutting at x-axis, the value of the function is 0. So if I put 0 here plus 2, I have minus here, I would end up getting x equals under root 2 plus minus. Do you understand this?
Yes.
Sure?
Yes.
Okay. All right. Now, what if
Wouldn't it be negative under root 2?
negative under root 2? Okay. Yes. You're right. Okay. But again, negative under root 2 would, end up getting complex values. So let's just change
Okay.
it. I will just change it. I'll tell you how. Let's do it for, I mean, if we have minus under root minus 2, we would, enter the complex plane in that case, right? So here we are talking about real numbers only. Okay? Do you understand why am I changing it?
Yes.
Let's use minus 2 here then. Okay. All right. Now tell me, how would the graph look like?
Minus 2. So if it's minus 2, that means it will move down 2 units.
Over here, right?
Yeah.
And it would be upward or downwards?
Downwards.
Like this, okay? All right.
Yes.
So here it is not cutting the x-axis, so we don't have to find the values and do it that way. All right. This is clear. Let's talk about a bit complicated version. The equation is y equals x minus 1 whole square this. Okay, now tell me. Yes, now tell me. Do you know how to plot this graph?
No.
No. Okay, I'll tell you. Now this is x minus 1 square, okay? We don't have a simple x square, but we have minus 1. Whenever we have minus and then a constant, it means that our graph would move to the right side. Okay. Initially, it is in the center. When we have minus 1, minus constant, it will move 1 unit to the right. Okay. All right. And we know what this minus 2 means, right? It means this, the graph would move 2 units down. So we had this graph. Look at this x squared. Can you see this x squared graph?
Yes.
Just move it to 1 unit towards the right side. This is 1. It would be here. And it is then 2 units down. So this is minus 2. It would be here. And it is going to be um, in the upward direction, right? and we need to find these points. Only then I can, it would be either like this, or it would be like this. Okay, so I don't know if it would be cutting this or this. We have to find that by finding the values. Okay, let's do it. We know that y would be 0 at the x-axis. So we have x minus 1 square minus 2. It is 2 equals x minus 1 square. We need to find under root 2 x minus 1. It is under root 2 plus 1 equals x. Okay, so this is basically plus minus, right? So one combination would be under root 2 plus 1, and the other one would be minus under root 2 plus 1 equals x. It is
Oh
x.
yeah, the giving root, so it's plus or minus.
Exactly. Excellent. Okay. All right. So this would be 1 plus under root 2. And let's see if the other one is 1 minus under root 2. So it is a negative value. It is a negative value. It is minus 0.414. So it would pass through the negative x-axis. Okay. Just for knowing where our graph would pass from, we need to find these values. Is it clear?
Yes.
Okay. And here, if we try finding out the values of x at the x-axis, we need to put 0 here. This is minus x square minus 2. This is 2 equals minus x square. I would have minus 2 equals x square. And since we have entered the complex planes, we write no solution here. This is why the graph is not cutting our x-axis anywhere. Okay?
Okay.
Okay. And yes, look, I did it correctly initially as well. I had plus here. I had plus here.
Yeah.
Okay, so that would have been minus 2 equals minus x square. Okay, so this would be positive. It would be plus minus under root 2x. In that case, we would not enter the complex plane. Okay,
Okay.
do you remember you said that it would be minus 2 under root minus 2?
Yes.
So it would not be. I think you messed up with this minus sign. We have a minus sign here as well. Okay,
Okay.
let me do it here. Okay, so initially, instead of instead of y equals minus x square plus 2, I wrote y equals minus x square minus 2. Okay, now we know that it is going to be this shaped parabola, and I need to go 2 units down. Okay, yeah. So it would be of this shape. And this should have been from somewhere. Wait. Okay. This is minus x square, right?
Yeah.
Let's plot for this. Okay. Now when we have x equals 0, this is the y-axis, okay? At y-axis, we have x equals 0. When x is 0, y would be 2. So this is given that our graph would pass through this point, okay? And it would go like this. These points would be 0 equals minus x square plus 2, minus 2 equals minus x square. So ultimately plus minus 2x. So this is minus under root 2. This is under root 2. Okay.
Will be
This
minus 2.
minus under root. Which one?
Uh, will be minus 2 equals minus x square, right?
Where? Where?
I mean, you're taking 0 equals minus x square plus 2. So if you take 2 to
Exactly.
the other side, it'll be minus 2. Oh, and then
Exactly.
you're canceling it.
Yeah, yeah, yeah. Yeah. Okay.
Okay,
This,
I got it.
yeah, this is the first type, and then we need to think about it with a negative sign. Okay. With a negative sign. Okay. Now initially, let's do it again by thinking of the simple graph and then by transforming it. So minus x square would be like this, right? And at y-axis, x is 0. So it is minus 2. And it would be a downward shaped graph. Okay, let's double check it by finding u equals minus x square minus 2. It would be 2 equals minus x square. It would be minus 2 equals x square. And now when we have to find the under root of minus 2, we know that it is a complex number and it cannot be dealt with in the real plane, right? So this is basically a double check of our graph. So do you understand? Did you understand this? Can you hear me? Okay. Ranjani, are you there? Your mic is mute. I can't hear you. I
Can you
still,
hear me now?
yeah, I can hear you now. Okay, I'm sorry. I don't know.
Yeah.
All right. So, did you understand the last quadratic graph
Yes.
tool?
Yes. Yeah.
Perfect. Okay. Now we can move on to our next question, which needed graphs. Okay. The question is, okay, so it has a big question. First part is draw the graph of y equals x square minus 7x plus 5. Okay. For x between minus 1 and 7, full stop. This is the first part. Then they are saying how many solutions are there to this equation in the given interval. Okay. All right. So this is a question. It is a very simple question. Let's think about it. and then you will solve it. Okay. So the first thing is you
We're
need
just supposed to substitute -1 and 7 into the equation, right?
exactly. Okay. Now you are very correct. If you substitute -1 and -7, I'll tell you one thing. You would be able to know if there is a solution or not, but you would, okay. And it could be that you are not able to know if there is a solution or not. What if, okay, this cannot be -1. This is -1 and this is 7. Okay, it is positive here and it is positive here as well. What if you have this type of graph? You have positive and positive here. So now sign is not changing, but again you have two roots. So you would be, they would ask you to tell if a root exists or not only if they are giving you two consecutive numbers, okay? Here we have -1 and -7, and another clue is that they are telling us to find how many solutions are there. How many? You need to tell the number of solutions. This method, this method of finding positive f and negative f works whenever you get positive and negative. Okay. This way, if you get it directly, yes, it 100% implies that there would be a root. But if you get positive and positive or negative and negative, it does not imply that you would not have a root. Okay? Do you understand this? I mean, if you
Yeah.
get positive function and negative function at the end points of your interval, it implies certainly that you have a root in that interval. Okay? But if you do not get positive, negative, if you do not see a sign change, you get positive, positive, negative, negative, you cannot say that there is no root. Why? It could be that this was your type. Now here at -7 we have positive, at -1 we have positive, at 7 we have positive. Still the graph is cutting the x-axis and we have two roots. Okay.
Okay.
So if you get positive and negative, you can say that yes, definitely it implies that we have a root. Yes. But if you're getting positive, positive, negative, negative, you need to do something else. And we are going to do that something else here. Okay. This is why they have asked us to draw the graph. With the help of graph, we will tell them. And another thing here is that we had to tell number of solutions. The positive negative method or the sign change method is its name basically only tells us to only tells if there is a root or not. Okay, it doesn't tell if we have how many solutions. Okay, if we don't get information about that in that case. All right.
Yeah.
Okay. So let's move step by step. Okay. So okay. Hmm. Let's do it by plotting the graph because this is what they are seeing. Let's try to plot this graph. But have you plotted a graph of this type ever before? I mean, do you know how to plot these graphs
Yeah.
of this equation?
Yeah, you just put random values for y and figure out x.
Exactly. Okay. Basically, you put random values of x, as in you choose x. You choose x as 0, 1, 2, 3. You get your y's, right? And then you plot your graph like this, and you disconnect like
Yeah.
that, right? Okay. This is a method, and this is what your book has, but no, but you will see that this method is not a good method. Okay, so we will do it again through this way. Okay, we know how to plot such graphs. If C is a number and A is a number, we know how to plot such graphs. Okay, we have just discussed that, and we will use
Yeah.
completing square to make this form, for our given equation. Okay, let's do it stepwise. Let's not take things. Let's not discuss everything initially. Let's just do the completing square method. Okay, solution for plotting complete the square. Do you know what is the completing square method?
Yes.
Very good, excellent. Okay, so we have y equals x square minus 7x plus 5. We need to, okay, in our equation we can always add subtract two numbers. Okay, I mean, I can say plus minus 2, I can always write plus 2 minus 2 because the effect of this 2 would be cancelled by this. Okay, I can write minus 3 plus 3. So mathematically it is correct. So mathematically I can write two same numbers with a positive sign and a negative sign here. Okay, and what are those two numbers going to be? We know that a minus b, or
You
let's,
just do it directly, like x minus 7 by 2.
yes,
Yeah.
yeah, exactly. Very good. So this would be 7 by 2 square
Yeah,
minus
7
7
by
by
2
2.
square.
Very good. Okay. This would be y equals x minus, because of this minus, okay? 7 by
Yes,
2.
x minus 7 whole square. Yeah.
Excellent. And this would be,
49 by 4.
yeah, okay. So it would be minus 7.25. Okay. All right. So we have done our calculations and this is what we got. And this is a time saving tip as well. Okay. Otherwise, you would first have to draw your graph to scale in other way. Okay. If you do by this method, if you choose x1, x0, 1, 2, 3, and you find your corresponding y's, first you will have to make this table, then you will have to draw a proper scaled graph. Okay, in our example we don't draw a scale graph, we just do it directly and then we write down, okay, the graph would cut x-axis at these points and y-axis at these points. But in this case it would take more time. Do you understand why it would take more time?
Yes.
Okay, so let's do it through our method. Okay, okay, all right, let's plot the graph now. Now we know the graph of y equals x square is a parabola. It is a u basically. But here we have minus 7 by 2 as well. And I told you, whenever we have minus something, it moves towards the right side. And if we had plus something, it would move towards the left side. Okay?
Side.
So this is a negative relationship basically. I mean, it's just a tip to tell you. This is x, this is y, this is the positive x-axis, this is the negative x-axis. Whenever you have minus something, it would move towards the positive side of x-axis. Okay, so think of it as an inverse relationship or negative relationship. Okay, all right. So it is your choice. Whatever way you will remember, you have to remember. Whenever you have minus some constant number, your graph would not be like this, but it would be moving towards the right side and it would move 3.5 units to the right. Okay, so it would be somewhere here and it would be in the upward direction, but we have this as well. So this is telling us that our graph would be at minus 7.25.
Yes.
This would be the vertex 3.5 and minus 7.25. You know what the vertex is, right? You know what the stationary point is.
Yes.
This is the stationary point of any graph. Okay, okay, of any parabola. Okay, so now we know that this would be the stationary point and we know that it would pass the graph from this side and somewhere either it would be like this or it would be like this. We need to make sure this thing. Okay. All right. And we will decide that by finding the roots. What are the roots? Values of x when y is 0. So 0 equals x minus 7 by 2 square. I don't know why my pen starts getting it to the weight. All right. So we have x minus 7 by 2 square minus 7.25. 7.25 would come to this side. We have x minus 7 by 2. We have square, this would become the under root, and the it would be with plus minus. So plus minus under root 7.25 plus 3.5 is x. Okay. So one value of x would be 0.81. I have already done that. And the other value of x is going to be 6.19. So it would pass through, oh sorry, like this. Did you understand this thing?
Yes.
Okay. All right. And I want you to tell me what would, do you have your calculator with you?
Yes, I do.
Okay. So what would be this value? You can use your calculator. It is the y-axis. The curve cuts the y-axis when x is 0. Okay. Remember at y-axis x is 0.
0.
So what would be this?
Yeah.
You need to use 0 instead of x. It would be 5. Okay.
0 minus 7.25. It will be 5.
Yes, very good. Okay. And this value is 6.19 and this value is 0.81. You need to be perfect at making the quadratic roots, okay? You should know that this is going to be 3.5. Oh my God, my pen is 3.5 and minus 7.25. You should know 1, 2, 3, 4 things, okay? You should know these 4 things and then you're good to go. All right. So we are done with the graphing part. The second part is how many solutions?
2 solutions.
Very good. Excellent. Just give me a second. I will reconnect. Okay. Can you hear me? Can you hear me?
Yes, I can.
Okay. So how many solutions? 2 solutions. Very good. Why? Because the graph is cutting the x-axis 2 times. Okay. All right. The second part is for the same question. The second part is show that x square minus 7x plus 5 is 0 has a root in interval Now we will use the method you expected, you wanted to use initially, okay? Now we will use that. So we have 0, we have 1, and tell me how are we going to do it?
By using the completing the square method.
No, 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 no. Just read the question again. This is the same question. We have already done that for it. Here they're just saying show that it has a root. You don't have to find number of roots. You don't have to find the roots. You just need to tell
You can
that.
just substitute 0 and 1.
Excellent. So 0 minus 0 plus 5 is positive, and 1 minus 7 plus 5 is negative. This would be 5, this would be minus 1. Okay. So since this the proper statement is there is a sign change between
0 minus 5, 0 minus 0 plus 5 will give positive, right? Oh yeah, it's a positive, yeah. Negative, because if 5 comes to the other side.
no, look, this is the function. Okay, this is basically our
Oh
y.
yeah, I got it. I got it. We are substituting inside the.
Yeah. Okay, so this just learn this type of statement because you need to answer properly. Okay, in marking scheme you will see that they want you to write it in a specific way. Therefore, there is a root of f of x in interval 0 less than x less than 1. Okay. So, did you understand?
Yes.
100%?
Yes.
Okay, perfect. Let's do the last question for today. So, the question is, show that sine of x is equal 0 has a root in interval pi by 2. Okay. Now tell me how are we going to solve this part?
You can just use sine pi by 2 equals 0 and.
No, sine, we will not use sine, exactly, you are right. I mean, we will just use sine pi by 2, okay? Because sine pi by 2 is not 0, sine pi by 2 is 1, okay? Don't get confused by
Yeah.
this and by this, okay? You can have either this or this. You will basically be using the same method. You have to insert this in x and this in x, okay? This is 1 and sine 3
Minus
pi
1.
by 2 is minus 1. Now this
Minus
is positive and this is negative. So you will say there is a sign change between between f at pi by 2. What is f? Sine x is f, okay? And f at 3 pi by 2. Therefore, there is a root of f of x in the interval this. And indeed, if we look at the graph of sine, it goes like this, and then we have this. This is pi, this is 3 pi by 2, and this is pi by 2. So this is the root they're talking about. It is positive function here, it is negative. So between positive and negative, the graph would certainly cross the x-axis, and this crossing is basically the root. Do you understand?
Yes.
100%?
Yes.
Okay, so we are done with this. I will share the practice questions of integration tomorrow. For now, I just want you to revise the whatever we have discussed in class. Let's stop the recording and then I will talk about it.